All right, good morning, everybody. So I hope you're doing great. As you can see, I'm here, but I'm not here. You can't really see. I take that back. As you can hear, I'm here, but I'm not here. So as usual, gang, let's go ahead and let's do the warm-ups that are in here. So you might not have the warm-ups in front of you, but go ahead, go to our Schoology page. You'll find the warm-ups there. I believe there's 5 questions, so pause the video. When you come back, they'll be on the next slides. You can check your work and see how you did. Again, this is all stuff over Unit 2, so it shouldn't be too bad. So anyway, pause this, go do those, unpause, and we will continue on with the show. Okay, so here we go. So 3 times the number decreased by 8 is blah, 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 blah. Alrighty. I believe this is going to be 3. Whoa, that is not the good writing utensil device. Let's go here. Alright. How about this one? Okay. 3n minus 8 equals negative 13. Again, just wanted an equation. Didn't need you to solve it or do any other fancy stuff. Alright, this one we did want to solve. When we solve for b, tough one here, we get 11. Okay. Next one, let's take a look here. N equals 6. Alright, absolute value one. Hopefully you have 2 answers. I do. Alright, in my best curly brackets, they are negative 13 and 7. That right curly bracket is awesome looking. And everybody's favorite literal equations. When we solve for b, we will get b is equal to negative 5rc minus a, all of that being divided by negative 2. Okay. Sweet, so onward we go. All right, so a lot of stuff going on here. Guys, we've got some new words here, standard form, constant, x and y intercepts. So just a quick reminder on some of these. First off, standard form, right, we will see right here, right, and it looks like this, ax plus by equals c. A and b are just the coefficients in front of those 2 variables, x and y. C is just a constant, right? X and y intercepts. So here we have a graph. There is a line that goes through our graph. So wherever our line goes through, right? So I would call this first one here, right? That is an x-intercept, and this one here is a y-intercept. I never write intercept, I just put int. Okay? I think that's all we've got as far as this goes. Okay, so that was easy, that was fun. All right, moving on. Okay, so one of the things we're going to have to do is identify if things are linear or if things aren't linear. All right, and easy way for us to do that is just to let's go ahead and rewrite the equation so that the variables are on the same side of the equation, right? So I've got variables on both sides, so let's just go ahead and move this xy over there. If we'd like to, we can go ahead and move 3 over to the right. So we're going to subtract xy from both sides, so minus xy. At the same time, I'm going to subtract 3 from both sides. This is going to turn into 2 minus 3, which I believe that to be negative 1. All right, and now we can kind of look at our equation, right? 5x, that looks good, right? When we think about standard form, you know, ax plus by equals c, right? We've got 5x minus xy equals 1. And since this term right here has 2 variables, this is not a linear equation at all, right? So this is not, these 2 terms, or variables I should say, can't be being multiplied together. That's a no-go. All right, so this one not linear or linear. Okay, second one, determine whether 3/4 x equals y plus 8 is linear. Again, want to do the same thing that we've been doing. Rewrite the equation so both variables are on the same side. All I really need to do, right, move y over here. It's a positive y on the right-hand side, so let's go ahead and subtract. Again, 3/4 x and y do not combine, so we just leave them like that, and we're done here. So this is in standard form. You know, is it technically wrong if you put the y first and said negative y plus 3/4 x equals 8? No, that's not wrong, but in standard form, we typically, you know, like to see it with x first and then y. You know, other than that, so yeah, the equation is in standard form, and it is a linear equation, right? For us, linear means a couple things. You know, linear means on a graph, a straight line. Linear also means to the first power. Okay, and so yes, everything, all of our variables are to the first power here. And I know what you're saying. Well, aren't these variables up here to the first power? And well, technically they both are to the first power, but they're both held together. So really, this term by itself is to a power of 2, if we want to think of it like that. And that's why that first example A is not linear, but B is linear. Okay, example 1 here. Determine whether y equals 4x minus 5 is a linear equation. Write it in standard form. So again, standard form just says x and y are going to be on the same side together. So we can do that. So here we go. Y equals 4x minus 5. Again, 4x needs to move over here. We're going to subtract it, right? Just like we've been doing. This is where our work with literal equations really comes through. And helps us here. And so, okay, let's say, yeah, negative 4x, if I can write here, negative 4x plus y equals negative 5. Yep, that works for me. You know, that was one move. What if you did the other way, right? What if you said, hey, you know what? I'd like the y to move over here to the right and move, you know, 5 over here. That's completely acceptable. All right, it's 2 moves instead of 1. I'm all about being more efficient, but this is just fine as well. You know, you would add 5 to both sides. Okay, at the same time, we're going to subtract a y from both sides. Right, so on my left-hand side, I would have 5 is equal to 4x minus y. All right, so you know, if we really analyze and look at these two, we see a lot of opposites here, and that's okay. Technically, these both mean the exact same thing. You know, if you'd like to rewrite this as 4x minus y equals 5, okay, that's probably even better, because now it really truly is in standard form because we moved the equal sign over here to the end. That's good. But you'll notice everybody is their opposite. So like this negative 4x, right, is positive 4x. You know, my positive y is now negative y. You know, 5 is I'm sorry, negative 5 is now 5 over here. So, and that's not by chance. That will always happen. And good news, it doesn't really matter which way we move. I just wanted to show you that you can do either one, and that's okay. All right. Again, here's another one. Determine if this one is linear and write it in standard form. So this one, you know, already kind of in standard form when we think about our variables gathered on the left-hand side, because, you know, really that's all standard form. We're going to learn lots of forms in Unit 3. Standard form is the first one that we will do. But standard form, yeah, it just says collect your variables on one side. So this is completely fine. But once again, this middle term has 2 variables tied together, so not linear, right? Not linear. It is Not good. Okay. All right, find the x and y intercepts of what we have graphed. That was my phone. Somebody's trying to get a hold of me. Should probably check that out. All right. So x and y intercepts. So here is my, there we go, we got it right. Here's my y-intercept right here. X-intercept down here. Again, where are they crossing this graph at? Okay, and you know, we read these graphs a lot like we read a book. We read from left to right. You know what I mean? So it looks like, let's go ahead. We'll work on our x-intercept first. What's that ordered pair? What is that ordered pair? I would say that's the ordered pair 4, 0. Right? That's where the line crosses the x-axis, right, at that point right there, 4, 0. And we're going to do the same thing up here. So what is this as an ordered pair? I don't even know what grade you guys started doing ordered pairs in or graphs. I think maybe 5th grade is when we do that. So the y-intercept, right, that ordered pair is 0 to 100, right? So for all of us that forget, in an ordered pair, it's the x value first and the y value second. I can't. Mr. Laver has a little saying like you have to walk before you can run or something. I don't know what it is. You have to. We'll ask him. Anyway, it's not important. What is important though is that here's our two intercepts. The y1 is at 0 to 100. The x1 is at 4 and 0. Okay. Same thing here. Now, luckily, you know, everything's turned into nice numbers here. You know, are we allowed to just say, hey, what number the x and y intercepts are? Yeah, I suppose that would be okay. I don't think it's a great habit. You know, you could say, hey, your x-intercept is at 10. You know, your y-intercept looks like about 250. All right, but you have to be able to identify that as an ordered pair. You need to be able to write it as an ordered pair, right? So as long as you can do that, you know, it's not the best habit in the world, but, you know, there we go. So there's that one. I don't have any room before that, so we'll have to write the y one there. Okay, look, that didn't take that much longer. All right, finally getting some fun stuff here. So now we're going to figure out our intercepts, what they are from a table. All right, and I'll show you guys how we can turn a table into a graph on Desmos. That's not what today is about, right? But we can find intercepts from a table, and it's really easy. We just have to think about, what does a table show me? Well, here, this table shows us time and weight. If we think of these as ordered pairs, right? Let's just focus in, right, on this one because I see a 0, and on that one because I see a 0, right? Now, they were nice enough to go ahead and tell me x and y, so we can say, hey, this is the ordered pair 0 to 1000. All right, where does that fall? Which intercept, which axis does that go through? This point down here is 500, 0. Okay, so again, this one right here is going to be our y-intercept. Why, you ask? Well, because the x value is 0 and the y value is 2000, right? Same thing holds true over here. This one's our x-intercept. Why is this one our x-intercept? Because this is the x value, 500, when the y value is 0. Okay. I think that was a lot of fun. Let's see what else we have. Okay. Jules has a gas card. Woohoo! Good for him. Again, the table shows what we got going on here with our function. We just have to determine x and y intercepts of the graph. Sounds easy enough. Again, I'm going to look right here, and I'm going to look right here. Did it tell me which variable is which? Oh no. So am I just to guess? Are we to assume that the first one is x and the second one is y? What do you guys think? Well, I would say we need to go back and think about what we did in Unit 1 where we figured out, hey, independent variable, dependent variable, right? So go back and remember, right, here is my little goofy phrase, y depends on x, right? Y depends on x. So y is the dependent variable, x is the independent variable. So then you just have to figure out you know, what you have going on. So it says the table shows the function relating the amount of money on the card and the number of times he has stopped to purchase gas. So does the amount of money depend on the number of times he stopped for gas? Or does the number of times he stopped for gas depend on the amount of money? Right? No, the first way I said it is the one that makes sense, right? So the amount of money depends on the number of gas stops, right? The more gas stops, the less money we have on this card, okay? So with that being said, if the money depends on gas, then the money is y and the gas is x, okay? So now it's just like the other one, but we know what x and y are. So moral of the story, don't assume, gang, when they give us a table that this first column is the x values and that the second one is the y's, because I guarantee you people are going to try to be sneaky and they're going to give you a bear trap and everything else, okay? So here we go. So 0, 1, 25, right? This is our y-intercept. Great. And then the other ordered pair, 5, 0, this is our x-intercept. Okay. Then it also wants to know, it says, describe what the y-intercept of 125 means in this problem. So the y-intercept is this ordered pair right here. Okay. So what does that mean? Well, that means at 0 stops, which is kind of weird, or before we made any, right? Here, I don't even like that. Let's just say before we made any stops, right? We had $125 on the card, right, on this gas card. So before we made any stops, we had $125, right? And that's something that we're going to have to work on throughout the year is reading a graph, or what does this ordered pair mean, or what does it mean in terms of this problem. So that's something that we'll have to get good at, and we'll just get more practice throughout the year, but there's one example of that. All right, another thing that we're going to do today, we will graph everything with Desmos, guys, but because I'm not here today, we're going to learn the freehand, super quick way to graph, all right, this right here, right? This is a linear equation. It's already in standard form, and we're going to graph it with intercepts. Like, think about that, right? If I know where a line, and remember, these are straight lines, if I know where it goes through the x and the y-axis, right, I can draw a line. You know, a line, I just need 2 points, right, to draw a line. It's, you know, it's a line, it goes on in both directions, you know, through those 2 points. So if I can figure out 2 points, one on the x-axis, one on the y-axis, I can graph anything. All right, now we can easily do this with intercepts if our numbers are nice. And today we'll see what some nice numbers look like. All right, so again, all we have to do is figure out, hey, where on my graph does this go through the x and the y-axis? All right, so to graph with intercepts, all right, we're gonna do both. So we'll figure out what our x-intercept is over here. We'll figure out what our y is over here. And you know, the first thing we need to do is make sure our equation's in standard form. This one's in standard form, so now we're ready to do something with it. And when we do that, literally, it's as easy as ignoring everything that is in the y. So if I want to find the x-intercept, what we technically do is set our y equal to 0, or we replace y with 0, right? So it looks like this. And now we solve our equation for x. Okay, so 4x equals 4, x equals 1. So again, this means we have an x-intercept at 1 on our graph. Okay, let's do the same thing with y. To find my y-intercept, I want you to replace x with 0. So again, it was 4x minus y equals 4. Now it becomes 4 times 0 minus y equals 4. Well, 4 times 0 is 0. Minus y equals 4. My equation here, though, not solved for y yet. It's solved for negative y, right, or negative 1y. In order to solve that for y, divide by negative 1, right? Divide here by negative 1. Divide by negative 1. Y equals negative 4. Perfect. All right, so there's my two intercepts. All right. And if we were going to graph it, here we go. My x-intercept is at 1. We'll say right there. My y-intercept is at negative 4. So negative 1, 2, 3, negative 4 right here. And then we would draw our line. It's not the super straightest line I've ever drawn, but that's okay. Okay, moving on. Is this the correct graph for, and then we get 2x plus 5y equals 10? Well, I don't know if it is or not, but let's figure out the x and y intercepts, and then I can tell you if it is, right? Like if we have like an x-intercept of 1 and a y-intercept of negative 2, well, I don't think those are shown on this graph. All right, so for our x-intercept, here we go. It's going to look like this: 2x plus 5 times 0 equals 10, right? Or 2x plus 0 equals 10. Solve for x. I get x equals 5. All right, so let's see if that checks out. Looks like 1, 2, 3, 4. Yeah, I'm okay with that. So that looks good. Y-intercept, same thing here. So now it's 2x, or 2 times 0, plus 5y equals 10. So this turns into 0 plus 5y equals 10. And this is always, guys, this always turns into 0, right? That's why we do this, because think about the ordered pair, right, that this makes. We want to know, hey, what's the y value when x is 0? That's why we do this. So here we get y equals 2. So 1, 2. Yeah, I'd say this graph checks out just fine. So is this the correct graph? For this one, yes, absolutely. Just a few more. Hang tight. Okay. Graph y equals 2x plus 2. Then state the domain and range. Oh, you mean to tell me we got to do domain and range again? Oh, okay. All right, here we go. So let's do this. Let's put this into standard form. So standard form says go ahead and subtract 2x, right, from both sides. So now I get negative 2x plus y equals 2. Okay, let's find our two intercepts. Okay, so we'll find our x1 first. So our x-intercept would say negative 2x plus 0 equals 2. Solving for x, I would say x equals negative 1. Okay, fantastic. Y-intercept. Again, just replace x with 0. So now it's negative 2. All right. People are texting me all over the place. Negative 2 plus y equals 2. Sorry, negative 2 times 0. So this turns into 0 plus y equals 2. And there you go, y equals 2. So we're going to make a graph. Alrighty. And we have an x-intercept of negative 1 right there. We have a y-intercept of positive 2. Boom, there we go. Alright, and again, we know these lines go on forever and ever and ever and ever. Okay, so there's what our graph looks like, guys. So now, again, domain and range, right? They will never, ever, ever, ever go away all year. So just remember them now. All right? Domain X values, range Y values. So domain, right? We're going to scan left to right, left to right. How far left does my graph go? How far to the right does it go? Well, my graph only goes to -3, but is that where this line stops? No. What about -4? Look, now my graph goes to -4, right? Ooh, now my graph goes to -5, right? But I know this line keeps on going forever, right? Just like I know it keeps going up forever, okay? So the domain, will it get to -10? Of course. -100, -1,000, -1,000,000. Yes, it will get to every single negative number, right? So our domain, I'm going to use fancy compound inequality today, because there's nothing better than me doing that than really trying to confuse you when I'm not there. All right, so -infinity, right, is where it goes, and then it goes all the way to, well, does our graph show positive, 1 and 2 and 3 and 300 and 3 million and 3 billion? Of course it does. So it goes from -infinity all the way to positive infinity, right? And this little 8, sideways 8, just like curly brackets, you'll get better at it. That's not a very good one. This is our symbol, all right, for Buzz Lightyear, to infinity and beyond, okay? So there's your domain. You could also say, right, all real numbers for the domain. That's A-okay as well, all right? Range, up and down, up and down. How low does this graph go? Okay, well, I don't even have numbers in here, right? How high does this graph go? Again, it goes on forever. So you could also say, hey, it goes from -infinity, right, to positive infinity. Okay. Again, we're dealing with Y values. So again, notice I used a Y here. I used an X here, right? That's on purpose. Domain X values, range Y values. Okay, there's a lot on that one. And last one. Is this the correct graph for this one? Okay. Well, let's see how our intercepts work out here for us. So, standard form says 3x, you got to move over. So we need to subtract you. So this is -3x plus y equals -4. All right, and this will be great and fitting because this is kind of where our intercepts method falls down, right? It stumbles, it stubs its toe, whatever you want to say. Doesn't work that great. So -3x, we're going to find the x-intercept, so we replace y with 0 equals -4. All right, so solve this for x. So -3x equals -4. So we do a little bit of division. X equals, be careful now, 4/3. Okay, there's our x-intercept. Y-intercept, so replace x with 0 and solve -4. This turns into 0 plus y equals -4. -4, there you go. So y equals -4. There's my y-intercept. Okay, so this one, yep, I'm good with that, right? That checks out. That is -4. All right, but I don't think we have the right x-intercept. And this is where it gets really tricky. Like, is it really easy to put a very accurate dot on this graph at 4/3 or 1 1/3? Well, I know here's 1, and here's 2, and here's 3. Well, 1 1/3, is that maybe right here? So I guess kind of. So clearly it's not, right? I think this is -4/3, right? I think we could make an argument for that, but it's not positive. So is this the correct graph for this one? Absolutely not. Okay. Whew, that was a lot we did there. So good job. Let's move on to our book practice. So look up on the board there. I think it should be up there. So book practice, self-check for 3-1. If you get both those done, I'm not sure who's in the room with you, but you can show them all your fancy work that you've done so far. they'll give you the homework. I should hopefully be back in time before class ends. My meeting's over at like 9, so I should be back in just a little bit to hang out with you guys. So anyway, I know you're off to having a great morning, and I will see you all very soon. All right, later.